Dear student, welcome to the lecture series of nanotechnology and material science. Today I am covering very important uh, process, which is basically it is a core of microelectronic industry, uh, nanoelectronic industry, material science and engineering, and also biotechnology, ceramics, and composite industry. And that technique is known as chemical vapor deposition. The student, chemical vapor deposition is a core technique of deposition of thin films. It is a core technique of a deposition of a powder material on the surface of a substrate. It is a core technique to deposit nanorod, nanowires, nanopillars, and even nanoparticles on the surface of the substrate by using chemical reactions on the surface of substrate. And due to chemical reaction on the surface of substrate, the desired material is achieved. So this means that chemical vapor deposition is a core technique of microelectronic industry, nanoelectronic industry, nanoscience and nanotechnology, material science and material engineering, and even it is a core deposition technique used in biomaterials and biotechnology. So this lecture will briefly outline about the chemical vapor deposition, that what is a chemical vapor deposition process, what are the type of chemical vapor deposition processes, what are the physical and chemical parameters need to be monitored if you want to deposit thin film, or if you want to produce a powder, nanoparticles or nanowires on the substrate of surface, how you have to manage those physical and chemical parameters in order to achieve a desired material. Furthermore, I will also briefly explain about the advantages and disadvantages of chemical vapor deposition technique. I will also explain about the applications of the chemical vapor deposition process, that what are the key applications of the chemical vapor deposition process, and at the end I will also explain that what are the possible setup which is generally used in chemical vapor deposition based instruments. So dear students, a chemical vapor deposition is well-established thermochemical technique for a deposition of wide variety of films with different composition and thickness down to a single layer of atom. So this means that the CVD process is basically, it is a thermochemical process. What did thermochemical mean? Thermochemical means that in a CVD process, a precursor material is introduced on a surface of a substrate, and due to a heat, the precursor material will chemically react with each other, and at the end, the film will be deposited on the surface of a substrate in a solid form. So this means the chemical reaction on the surface of substrate will occur due to a heat. So CVD is a thermochemical technique, and due to this technique basically we deposit wide range of thin films. We deposit thick films which are in the range of micrometer, and also we can deposit a thin film which may be in the range of nanometer. And even, dear student, with chemical vapor deposition process we can deposit ultra thin films. Ultra thin films are films which are in the range of few nanometer, or which are in the range of angstrom. So basically with this technique we can basically produce wide range of different types of thin films lying in the category of ultra thin films, normal thin films, and the thicker films which are in the range of micrometer. We can basically, with this technique, different type of compositions of thin films may be prepared. So in a simple word, CVD is a process. It is a thermochemical technique which is used to deposit wide variety of films with different composition and thickness down to a single layer of an atom. So if I summarize, CVD is a thermochemical process. Thermochemical mean a process in which a reactant react on the surface of a substrate due to a heat, and due to thermochemical reaction you can deposit ultra thin film which are in the range of few atom, and you can deposit thin films which are in the range of few hundred nanometer, and even you can deposit a thicker films which may be in the range of few hundred micrometer. So student, CVD process is, let's define the CVD process. Chemical vapor deposition process is a process in which a substrate is exposed to one or more volatile gaseous phase precursors which react and decompose on the heated substrate surface from form non-volatile thin film, powder or single crystals. So if I elaborate this statement, CVD is a simple process in which a precursor material, a material which we want to deposit, is introduced in a reaction chamber. That precursor material reach to the surface of the substrate, and on the surface of the substrate the precursor material react with each other due to heat, and after reacting the precursor material get deposited onto the surface of substrate, where the precursor material is decomposed and converted into a solid phase thin film. So students, please keep in mind that the chemical decomposition is also known as a chemical breakdown. So a chemical decomposition or a chemical breakdown is a process, or it is effect of a simplifying a single chemical entity into two or more fragments. So basically, in chemical vapor deposition process, initially the precursor material, which are basically a reactant material, is introduced inside the reaction chamber, and when the precursor material reached onto the surface of the substrate of the reaction chamber, due to a heat the precursor material get decomposed. Basically they get separated into two or more fragments, and due to decomposition, due to a heat, the material on which is precursor, they will chemically react with each other. They decompose due to a heat, and then they get deposited onto a surface of a substrate as a thin film, or as a powder, or as a single crystal. So if I summarize the chemical vapor deposition process in simple word, chemical vapor deposition process is a process in which a chemical precursors, which are usually organometallics or halide compounds. So in chemical vapor deposition process, the volatile organometallic compounds or halides precursors are introduced in a reaction chamber, and these organometallic chemicals or precursor material, when they reach to the surface of the substrate, they interact chemically with each other due to a heat, and due to interaction of the chemical precursors on the surface of substrate, due to heat, the precursor material get decomposed on the surface of the substrate, and at the end they form non-volatile thin film or powder or single crystal. So in a simple word, in CVD process, you can basically prepare thin film, powder material, and even a single crystal on the surface of substrate by chemical decomposition on the surface of substrate due to heat. The student, there are different ways to produce a powder, usually a nano powder, even nanorod or a nanowire, or single crystal, and as well as thin film on the surface of substrate due to a CVD process. Let's say you want to prepare a single crystal on a surface of a substrate due to a CVD process. For this, you need to have a single crystalline substrate. So that single crystalline substrate in a CVD reaction chamber act as a prototype, or it act as a seed. So when the precursor material introduced on the surface of this single crystal seed or single crystalline substrate, if there is less lattice mismatch between the chemically prepared material on the surface of the substrate and a seed which is a substrate, then the deposited material which is formed after a chemical deposition of a chemical precursor, it will basically attain a same directional orientation of the seed material or of the substrate material. So in this way, a single crystal material is produced by a chemical vapor deposition process. In order to achieve a nano powder or nano pillars or nanowire, there are different types of templates used on the surface of the substrate, like mesoporous silica, etc. So on the basis of the template, usually the chemical reaction occur on the surface of the template which is placed on the substrate. And if there are a different kind of pores present on the substrate with the different shapes, on the basis of that, basically you can achieve nanowire or nanopowder or nanoparticle onto the surface of the substrate. In order to get a thin film, basically a chemical reaction basically directly take place on the surface of the substrate, and due to a heat, a chemical precursor get decomposed and convert into a solid phase or solid state thin films. Students, please note that the temperature of a substrate and as well as the temperature of in the reaction chamber is different, and on the basis of that, the difference of the temperature gradient, basically the substrate, the thin films or the material basically which is a precursor which is decomposed, get deposited onto the surface of the substrate. The variation of temperature in CVD process is very important. Basically, heat get transferred from higher region into a lower region. The temperature of the substrate is lesser than the environment of the reaction chamber, and on the basis of that, the reaction can take place easily and the material get easily nucleated on the surface of the substrate and is converted into a thin film or a powder or a single crystalline material. So you have to consider the temperature and a pressure of the reaction chamber for getting a desired thin film, powder, or single crystalline material. So let's summarize this. CVD process is a process in which a chemical reaction takes place between a chemical reactant or precursors on the surface of the substrate, and due to a chemical reaction the precursor materials get decomposed and they convert it on the surface of the substrate into a thin film, powder, or single crystals. Thin films deposited by a CVD or by a chemical vapor deposition give rise in change in physical, chemical, and tribological properties on the surface of the substrate, which mean the property of the bulk of the substrate is different than the deposited thin films. So now question here is that why we need to deposit a thin film on a surface of the substrate. Student, please note that substrate is act as a bulk material. Usually thin films are deposited on bulk material to get a properties different than the bulk material. This means that the bulk material has a different properties. So in order to achieve a different properties from the bulk material, thin films are usually deposited. So when the thin films deposited on the surface of the bulk material, physical properties, chemical properties, and tribological properties of this surface of the material get changed with respect to the bulk material. So basically, if you want to change physical properties, chemical properties, or tribological properties of the material from the bulk material, then you can deposit a thin film of your desired requirement. But keep in mind, student, in order to deposit thin film with CVD process, you need to consider the lattice mismatch of the desired material with respect to the bulk material. If there is a variation, or if there is a larger variation of lattice mismatch between deposited thin film and the bulk material, then there will be a stretching between the interfaces of the deposited thin film and bulk material, which basically will damage or which will cause a defect in deposited thin film. So in that case, you cannot achieve a high quality, textured, well oriented thin film with desired physical, chemical, or tribological properties. So in order to get a desired physical, chemical, and tribological properties, you need to deposit a thin film on the surface of the bulk material or on the surface of the substrate with closer lattice matching. Okay, if the lattice mismatch is higher, then you cannot achieve the desired physical, chemical, and tribological properties. This one just for information. The word tribology usually mean wear, friction, and lubrication of the material. So basically, you are not only use a chemical vapor deposition process just for changing a physical and chemical properties of the material, but you also use a chemical vapor deposition process for changing mechanical properties, like you can basically change the wear resistance of the bulk material or friction of the bulk material. So if I summarize chemical vapor deposition process is a process which give rise of change of physical and chemical and as well as tribological properties of the material on the surface of the bulk material, which means that the property of the bulk material is different than the properties of the deposited films. So basically, you can achieve physical, chemical, and tribological properties of the material which is desired for you on the surface of the bulk material with different physical, chemical, and tribological properties as compared to deposited thin film. Students, please note that chemical vapor deposition process is also known as vapor phase epitaxy. So chemical vapor deposition process may be known as vapor phase epitaxy when epitaxial films are produced via CVD, which are formed due to a chemical reaction between two or more gaseous phases. So, chemical vapor deposition is known as vapor phase epitaxy process. Basically, in chemical vapor deposition process, the chemical reaction between a reactant gases or a precursor gases take place on the surface of the substrate. And due to a chemical reaction on the surface of the substrate, if we achieve epitaxial thin films, then such type of process, in that case of achieving an epitaxial thin film, is known as vapor phase epitaxy. Please note that the word epitaxy means an orientational and well-directed thin films. So in a case when you achieved a thin film with well direction and well orientation and uniformity, then such type of thin films which are deposited from chemical vapor deposition process are known as epitaxial thin films, and the process is known as vapor phase epitaxy. So in chemical vapor deposition process, if you achieved a epitaxial thin film, then such type of chemical vapor deposition process is known as vapor phase epitaxy. Please note that usually in chemical vapor deposition process, the precursor material are introduced like this one, this bluish one and this reddish one. These represent a precursor material. Precursor material in a gaseous form are introduced inside the reaction chamber. So when the precursor material are introduced inside the reaction chamber, there is a heating environment inside the reaction chamber. So the precursor material will interact inside the reaction chamber and on the surface of the substrate. Usually the precursor material introduced in a reaction chamber are introduced in a reaction chamber by a carrier gases, and when the precursor material reach onto the surface of this substrate, the precursor material basically which are in the form of a gas molecule react on the surface of the substrate, and at the end of the day they get condensed and converted into a thin film. So in a simple word, student, in chemical vapor deposition process, you can basically use different type of wide fan of reactant, and these reactant react on the surface of the substrate and they get converted into thin film or nanopowders, particles, wires, and even single crystals. Just please note that even you can have a chemical vapor deposition process by converting a introducing a single precursor material onto the surface of the substrate. So that single material may react with the surface of the substrate and they can be converted into a thin film. Okay. So chemical vapor deposition may be a multi-component deposition technique where you can introduce a wide range of different types of precursor gases, and it may be a single, or you may introduce a single gas or precursor material onto surface of substrate. Another interesting point to notice here is that you can also deposit a layer by layer type of precursor material onto the surface of the substrate using chemical vapor deposition process. This is very important point for researchers. So initially in chemical vapor deposition process you introduce a different kind of organometallic precursors. Okay, these precursors get chemically reacted on the surface of the substrate and then they condense and convert it into thin film. So in case if you introduce different precursors at different time, let's say if you introduce one precursor in one time and it get deposited onto the surface of the substrate, so you will get a one layer of a deposited thin film on the surface of the substrate. So after some time, if you introduce another precursor onto the surface of the substrate, so you will get deposited a thin film of another material. So in this way basically you can even deposit a multi-component thin film onto the surface of the substrate. So such type of chemical vapor deposition is known as pulsed chemical vapor deposition or controlled injected chemical vapor deposition. So the pulse or the controlled injected chemical vapor deposition mean that you can basically deposit a layer of different types of precursor material in different time. So in this way basically you can deposit a layer by layer depositions of different material on a same substrate. So on the basis of that you can get different properties from the substrate. So this is a kind of advanced way of getting interesting properties from the material by using a layer by layer deposition or by using a sequenced layer by layer deposition on the surface of the substrate. Usually in general CVD processes you use a wide range of precursor material. You introduce them you introduce multi-component precursor material at the same time and they react on the surface of the substrate, which is basically it is a hot substrate, is hot, and the chemical precursor which are introduced onto the surface of the substrate by a carrier gas, they react onto the surface of the substrate and at the end they get converted, they get condensified and converted into a thin film. Then please note that there are two different types of reactor or reaction chamber used in CVD systems. Reaction chamber is a chamber which is used or in which a chemical reaction takes place. So please note that usually the reaction chamber which are used in vacuum based techniques are based on fused quart glass. Okay, so there are two types of reaction chamber or reactor used in CVD process. One reaction chamber is known as closed reaction chamber. So in closed reaction chamber, initially a precursor material in a form of gas is introduced in a reaction chamber, and then the reaction chamber is closed. Okay, so there is not a continuous flow of the precursor material after the reaction chamber get closed. So the closed reaction chamber are rarely used in chemical vapor deposition process because you cannot control the flow of the precursors inside the reaction chamber if the reaction chamber is closed reaction chamber. So you have to introduce the precursor material at once in a gaseous form, and then the reaction chamber will get closed, and at the end you cannot get a controlled deposited thin film onto the surface of the substrate. So in order to achieve a controlled deposited thin film onto the surface of the substrate, you need to have an open reaction chamber. Basically, open reaction chamber consists of a continuous flow of a precursor material in a chamber. Please note that CVD process usually use an open reaction chamber. The precursor material in open reaction chambers are not present inside the reaction chamber. They are operated from the outside of the reaction chamber. So the precursor material in a gaseous form are introduced from outside of the reaction chamber into a reaction chamber, and the flow of the precursor material in a gaseous form is continuously introduced inside the reaction chamber, and you can basically monitor the rate of the flow of the precursor material inside the reaction chamber. There is a device which is known as mass flow meter. So on the basis of that, you can basically check that how much precursor material is introduced inside the open reaction chamber. So in that way, from external, you can introduce a precursor material inside the reaction chamber, and in a controlled fashion you get chemical reaction onto the surface of the substrate, and at the end of the day you get thin film deposited on the surface of the substrate. So in a simple word, if I conclude, the CVD systems basically consist of two types of reaction chamber. One reaction chamber is known as closed reaction chamber. In closed reaction chamber, the precursor material in a gaseous form is introduced just only once, and after that reaction chamber get closed, so you cannot get a controlled thin film inside the reaction chamber. Whereas another type of reaction chamber used in CVD system is known as open reaction chamber, which involve a continuous external flow of the precursor material in a gaseous form inside the reaction chamber. And this open reaction chamber are open reactor, basically it gives you a variety of controlled deposition of thin film. So most of the CVD systems are based on open reaction chamber systems. Please note that chemical vapor deposition process basically gives you a high quality, high performance, well oriented textured solid material in different forms. So basically this technique is very important in order to achieve well textured, well oriented, high quality material. You can basically prepare different types of well textured, well oriented, a high performance material from chemical vapor deposition process. Some of the type of material which may be produced by chemical vapor deposition are as you can basically produce different types of thin films with help of chemical vapor deposition process. Thin films are basically the layer of material whose thickness is in a range of few nanometers to few micrometers. Apart from depositing a thin film with a chemical vapor deposition process, you can also deposit ultra thin films in a range of few angstrom. You can also deposit a macro thin film which are in the range of micrometer. So basically with chemical vapor deposition process you can deposit thin films. These thin films may be ultra thin films and they may be macro films. Apart from thin film, with chemical vapor deposition process you can deposit nanoparticles. Nanoparticles are very small particles whose diameter is in the range of few hundred nanometer. So chemical vapor deposition process give you an opportunity to produce nanoparticles on the surface of the substrate or on the surface of the bulk material. There are different ways to deposit a nanoparticle onto the surface of the substrate. Usually templates are used to deposit the nanoparticles. Some of the common templates are zeolite or mesoporous silica. The mesoporous silica have a different kind of pores with a certain diameters in the range of few nanometer. So the mesoporous silica is usually placed, or template is usually placed on the surface of the substrate, and chemical reaction usually take place on the surface of the template which is placed on the surface of the substrate. So in that way the pore of this template material get filled and the size of pore is in a few nanometer. So the template after the filling of the pore is just removed by different mean, usually microwave kind of or mechanical methods are used to remove the template. So at the end the material or nanoparticle which basically passed to the pore is deposited onto the surface of the substrate as a nanoparticle. So with chemical vapor deposition process you can produce a nanoparticle on the surface of the substrate. Student, you can also deposit or you can also produce a nanorod or macro rod on the surface of the substrate by using chemical vapor deposition. Student, please note that nanorod is a rod which have a diameter in nanometer, though the length of the nanorod is maybe in few hundred micrometer. However, the diameter of the nanorod is in few nanometer, in few hundred nanometer. Similarly, macro rod is a rod whose diameter is in micrometer. So basically, student, you can produce a nanorod and macro rod with a chemical vapor deposition process. Student, here I have one question: why we need to produce a nanorod on the surface of substrate? Student, please note that usually material, if it is present in a bulk form, so there the behavior of the material like a macro rod material is not a quantum mechanical behavior. So material behave like a normal bulk material. However, if you deposit a material in a range of nanometer, then the surface energy of the material which is in the range of nanometer is too high, and which basically cause a quantum mechanical effect due to a small diameter. And that quantum mechanical effect basically change the physical, chemical and tribological properties of the material. And that's the reason, that's why Richard Feynman said that there is a plenty room at the bottom. So if we get a material with a very smaller diameter in the range of nanometer and even below, you will get very interesting properties. And that's the reason in microelectronic industry or nanoelectronic industry, thin films in the range of few nanometer and even ultra thin films or smaller diameter nanoparticles or nanorods are prepared to achieve interesting properties on the surface of the substrate. Students, please note that with chemical vapor deposition process, you can produce nanowires. Students, please note that nanowires are generally in the range of 1 to 100 nanometer. Okay, and they basically, due to a smaller scale or due to a smaller diameter of nanowire, interesting properties may be achieved. The first nanowire was basically developed in 1987 in Bell Lab, and they observe the quantum mechanical properties associated with these smaller diameter nanowires. So with CVD process, you can basically prepare nanowire. If I summarize in a simple word, you can achieve different form of materials by chemical vapor deposition process. You can deposit thin film by chemical vapor deposition process. You can deposit nanoparticle, or you can produce nanoparticle on the surface of the substrate by chemical vapor deposition process. You can produce nano rods on the surface of the substrate by chemical vapor deposition process, and even you can produce nanowires onto the surface of the substrate by chemical vapor deposition process. Student, please note that in chemical vapor deposition process, the precursor materials are introduced in a gaseous form in reaction chamber, are decomposed and reacted on the surface of the substrate inside the reaction chamber due to heat, which is caused by a high frequency voltage IR lamp or other heating technique for the decomposing the reactant gases. So now question here is that As I have previously discussed, in a CVD process, we introduce a precursor gas in a reaction chamber. So, in conventional CVD process, the precursor gas is basically heated in a different ways. Usually, IR lamp are used, which basically increase the temperature of the reaction chamber, and they basically, due to higher temperature, when the precursor material reach to the surface of the substrate, they get decomposed and they convert into a thin film. Apart from conventional IR lamps, there are different ways, like you can basically introduce a radio frequency power or high voltage RF powers, which basically convert precursor material, which is in the form of gas, into a plasma. And after the conversion of precursor of the material into a plasma, they get reacted onto the surface of the substrate and converted into a thin film. So, dear student, usually conventional CVD use different types of heaters, which are maybe based on filaments or they may be based on IR lamp, but you can also use different types of radio frequency power sources, which basically convert the reactant into a plasma and which is then chemically reacted on the surface of the substrate and converted into a desired thin films. Student, please note that during a chemical vapor deposition process, frequently volatile byproducts are produced, which are removed by gas flow through a reaction chamber. So, as I previously discussed, in chemical vapor deposition process, a carrier gas basically take the precursor gas into a reaction chamber. And in the reaction chamber, the carrier gas get chemically reacted on the surface of the substrate, and then it get converted into solid thin film. However, during the chemical reaction, there is also byproduct produced. This byproduct, which is additional product to the deposited thin film, is removed by the same carrier gases which are used to take a precursor material into a reaction chamber. So the same carrier gases will remove the byproduct and they will take the byproduct into exhaust scrubber, where if the byproduct is hazardous, will be converted into environmental friendly material by doing different type of chemical reaction, and then they will get exhausted from the CVD system. Consider TiCl4, titanium tetrachloride. If TiCl4 is a chemical reactant in a CVD process, usually hydrogen gas is used as a carrier gas. So hydrogen will basically take the TiCl4 onto the surface of the substrate, and at the same time hydrogen react chemically with TiCl4 and get converted into HCl. So the HCl is basically, it is a byproduct which is produced due to chemical reaction of chemical gas and TiCl4. This byproduct is removed by the carrier gas, which is also hydrogen, and this byproduct is then removed and it just reach to exhaust scrubbing system, which is usually consists of a water, but it will react with the shower of water and will be converted into environmentally favorable material, and then it will get exhausted from the CVD system. So in a simple word, dear student, In CVD process, during a chemical reaction between the precursors material on the surface of the substrate, there may be produced chemical byproduct, and these byproduct or get exhausted by using the same carrier gases which are used to bring the precursor material on the surface of the substrate. So the exhausted byproduct is usually passed through a exhaust scrubber, which convert a byproduct into environmentally favorable material, and then they get exhausted from the CVD system. Okay. Please note that the chemical reaction usually take place in CVD system is in the range of a temperature 600 degrees centigrade to 1100 degrees centigrade. So the temperature of the reaction chamber in CVD systems is in the range of 600 degrees centigrade to 1100 degrees centigrade. This means that CVD process is a high temperature process. Basically, you produce thin films, nanoparticle or nanorod or nanowires in CVD process at higher temperature. So if I conclude, in CVD process, the precursors are introduced in a gaseous form in reaction chambers or decomposed and reacted on the surface of the substrate inside the reaction chambers. During the deposition, frequently volatile byproducts are produced, which are removed by gas flow through the reaction chamber. So same carrier gas will basically which bring the precursor material onto the surface of the substrate. The same carrier gas will remove the byproducts and will take those byproducts into exhaust scrubber and then to exhaust system, and from the exhaust system they get removed to the environment. Just please note that CVD is a versatile technique, and it basically produces wide range of thin films, nanopowders, nanoparticles, nanowires, fibers, and monolithic part. So it is a very diverse technique. You can produce wide range of material from this process. CVD can produce almost all metallic and non-metallic elements and compounds such as carbon, silicon, carbides, nitrides, boride, titanates, etc. So basically with this technique you can produce even element and different types of compound with high purity. So this technique is very diverse technique, and that's the reason it is a very important part of the microelectronic technology. CVD is a major part of semiconductor devices fabrication industry used to deposit thin film for device circuitry. So this means that CVD is a core technique of microelectronic industry. The devices which you see like memories, hard drives or ICs, they are based on the chemical vapor deposition setups. The thin films which are produced in different types of microelectronic devices are based on chemical vapor deposition systems, or are deposited or produced by chemical vapor deposition process. Chemical vapor deposition process produced ultra hard coating, synthetic diamonds, and diamond-like coating. So basically, if you want to have a material with very good qualities in terms of hardness, you can deposit synthetic diamonds or diamond-like coating by chemical vapor deposition.